Hey everyone, it's Miss Bell here from the Science Lab again, and today we're going to be talking about force and motion. However, before we really dive into forces, we need to talk about motion and what that means. And motion just means any sort of type of movement. Whether it's fast or slow, whether you go a short distance or a long distance, but you're always going to have a starting place, and then you're going to move, that's your motion, and you're gonna have an ending place. And there's a lot of different things to think about when it comes to motion, such as how do you get there? What kind of pathway do you make when you go from one place to a different place? Do all objects move in the same way? So right now we're gonna look at a bunch of different things and we're going to discuss motion. Here we go. So when we talk about motion, you have to keep a few things in mind. Obviously, motion means when something moves from one place to a different, but you have to kind of compare it to a reference point. So take my giraffe, for example. My tree is stationary. It's not moving when we go outside in nature because trees don't move. But my giraffe, which is a living object, can move. So it is getting closer to the tree. That's the motion or the movement of my giraffe. Over here, my stop sign acts as my reference point. So my stop sign is not going to move. Traffic signs don't move, but the people or the cars around them definitely have motion or movement. So here's my starting point for my car, and I can move the car to its ending point or ending position. So it started in a position, it ended in a different position, and then we are able to see that motion take place. When talking about position, that just means where an object is either located or where it's been put or placed. So right now, my polar bear is sitting on top of my Kool-Aid container. You could also say it's above my Kool-Aid container. So that's where it currently is. However, if I move it, it now has a new position. It is in front of my Kool-Aid container or next to my Kool-Aid container. And the same with my bumblebee over here. It is close by my cup, so here is its position where it already is located, and then I can move its position to where it's on top of my cup or above my cup. And now I want you guys to think about position. And remember, when you think about position, you have to take an object in motion, that's going to be me, and compare it to an object that stays put and is stationary. So right now, my little blow up Earth right here, my little blow up globe is going to stay put and not move, and I'm going to be the one that's moving. So here is my first position. How would you describe that in relation to the globe? Would you say what? Maybe I am standing next to the globe, or beside the globe, or to the right of the globe. All of those would make sense for sure. But here's my motion. And here's my second position, right back here. How would you describe my position now when being compared to the globe? Would you say I'm now behind the globe? Because that definitely makes sense. So I had my beginning position right here. I moved. I now have my end position, and we compared my placement to the globe, since this stayed still and never moved. Another thing you can think of when you're talking about motion is the speed of an object. And that just means how fast or how slow an object moves. Now, right now I have a tennis ball and an empty soda can, and there's no movement. There's no speed with these objects right now because they're sitting still. However, if I use some sort of force to push them away from me, they're going to move and they're going to have a certain speed. So here I have a tennis ball, and I'm going to try to push it away from me slowly. And here I have a soda can, and I'm going to do the same. It moves slow. I could also try to move them pretty fast, like this. Here we go. So practice going different speeds of different objects, animals, or people. Think of that turtle. What would a turtle look like when it's moving? You try it. Really slow. Now think of a really, really fast runner, maybe in the Olympics or some sort of sports game. Think how they look when they are running. Try it. They're going faster than that turtle. When talking about a object that's in motion, we have to know that not all objects move the same. And it depends on what shape that object is. Out here in front, you can see all these different types of geometric shapes, and they're all three-dimensional, meaning they have volume, they have lengths and widths and heights and take up space. Over here, my Kool-Aid container is a cylinder, meaning it has two bases that are circular shaped and they're flat. However, right here, this side of the container is rounded. So this is going to be able to roll on the table. However, if I try to roll my container this way, it's not going to happen because it's flat. I can slide it, but I cannot roll it. So you need to pay attention to whether an item has edges or corners or even flat surfaces. My tissue box right here has edges all around here. And that's where a flat surface meets a flat surface. So there's edges all around this rectangular prism. But because there are flat surfaces and edges, I can't roll it. If I did, it would look like this. And that's not a rolling motion because I'm the one who's having to change what is happening to the movement of my tissue box. But I can slide it. Now, one different type of motion that you can see from an object is what we would call rolling. And that just means that that object is turning over and over and over again, almost like my dots right here from my container. First the red is on top, then the blue is on top. You can see how I'm rolling this container forward and backwards, almost the same as my little egg right here. Or my water bottle, it's going over and over and over. These are all examples of an object rolling. Another type of motion that objects can make is a sliding motion. Think of this as a snowy, icy hill. And think of this as a really cool sled that you have that you want to ride down the little hill on. So you take your sled, you walk it all the way up to the top of the hill, and then you sit on it, you let go, and you let gravity pull you down. Watch what happens. You slide down the hill on top of your sled. And I want you to see this sliding motion of these objects. Here we go. I'm gonna slowly lift up this tray, slowly elevating this tray, and you're gonna be able to see each of these objects move or slide down the tray in a sliding motion. Another type of motion that objects can make is a spinning motion. And what that means is an object twirls around in almost like a circular path from some sort of points, or what we call an axis, like an invisible line going through the center of an object. Here I have our globe right here, and it is spinning around on that tilted axis. It's connected here on top and here on bottom, and it's able to spin around and around, or twirl around and around. Now take, for instance, my bottle right here. If I lay it this way on my mat and I use this type of motion, the circular twirling motion with my hands, I'm able to get a spinning motion from the bottle. Also think about a pinwheel, almost like my globe right back here. It has a point or a center point or some sort of axis that it is spinning around in that circular motion. Now I want you guys to try all of those different types of motions. Let's start with, what was the first one? Oh, rolling. So let's have our arm as our ground, and let's see a rolling motion, right? So it's like a ball being rolled over and over on itself on the ground. Now let's see that sliding motion. So here's my ground, and I'm sliding it. So the same area of my object is sliding against my flat surface. Now let's see that spinning motion. So here's my ground again, and then I have something spinning kind of in one place. When you also talk about motion, there are certain pathways that objects will take whenever they are moving from a beginning position to an end position. And one pathway might be in a straight line. Take, for instance, this tennis ball. I can push it and it goes straight across my board. I can also take my motor car and see it run in a straight line, like such. I can take my can, my cylinder can, give it a push, and it will move in a straight line. There's also a curved motion where an object will leave a path that's curved, and it goes off to one side, either maybe the right side or the left side. So it's not straight, it is curved and rounded. There's also the pathway of zigzag. Think of yourself in an arcade, you're playing air hockey with a friend. You take the little hockey puck and you place it down, and you use the stick to hit it on the board where air is moving the hockey puck. Now the hockey puck might go in a straight pathway, but once it hits something, it will change position, and it might look something like a zigzag on the board, like this. Another motion, or pathway that can be seen is maybe like a wavy or a curvy pathway. I have a metal spring right here, and it is kind of lengthy and heavy and loud, but I want you to think of it as a snake, and think of the way that snakes move against the ground. You can definitely see their pathways if they're traveling on top of sand. You can see that curvy, wavy track that they leave. So here I'm going to show the motion of rolling. I'm going to use some green paint to help me out, and I'm going to grab items that I know will roll. I'm going to have a starting position right here, and I'm going to roll my ball, and you're able to see the pathway of my ping pong ball. Again, here's my golf ball. There's that pathway. And here's a smaller ball that I have. Really straight line on that one. Let's go with a cylinder right here. Here's my green paint on my cylinder. Here's my starting position and my ending position over there where it hit the edge or the rim of my little container right here. Here's another bouncy ball, kind of a slower speed. Here's a cone where we're gonna see it roll on itself, kind of in that circular motion. Here's a cup. Okay. And here is that rolling motion of the cup. Kind of a curved pathway. And last but not least, let's get a little bit more paint. Here is my paper towel roll. We know paper towel rolls are in the shape of a cylinder, even though they're missing the two bases. But here's that pathway. You're able to see it moved in a very straight pathway. Now, what if we talk about the motion of spinning? Okay, here I have some purple paint. Instead, here's my toy top. I'm gonna dip the very tip of my top in the purple paint, and I want you to see what kind of motion that paint leaves. Okay, it didn't go straight like some of our green paint did. Instead, it kind of swirled and moved just a little bit, but for the most part, it spun in place because of that spinning motion. I'm gonna do the same thing, but with my little jack right here. I want you to see this spinning motion. Whoops, my jack kind of hit my top, so let me try again. Let's go up here. There's a really good image of that spinning motion from the toy top. Maybe Miss Bell just isn't very good at spinning things in place. But you can definitely see the difference in what the green and the purple paint looks like. Spinning and spinning and spinning in place, you can see what that purple paint looks like compared to the straight lines that our other objects made.
And here I have a tray with shaving cream mixed with a little bit of water, and I placed some objects on top, and I'm lifting my tray up high into the sky slowly so that we can see the sliding motion of these objects as they go down the tray. So let's speed it up so that we can see these items sliding down the tray. So you're able to see those straight pathways as the items move from the top of the tray all the way down to the bottom of the tray. And that's about it when it comes to motion. Here I am just having fun in the science lab, kicking this ball around. But it's not just that. There's force, there's motion, there's a starting point, an ending point, there's speed and direction. Science is so cool and so fun. I hope you guys enjoyed this. Bye, guys.